epithelium, here also epithelium, this epithelium, this and this epithelium, this also epithelial cells, and in spite of that, all types of epithelial tissue has the same features. And these features you can see here, morphological features of epithelial tissue. Epithelium is localized on the border between exterior and interior. Look please. What this is exterior for the body, for example, this interior. So it's situated on the borderline between exterior and interior. Epithelium form continuous layers using intercellular junction. Look please, we can see that cells situated very close to each other. To keep themselves very close, necessary to contact, to form an intercellular junction. Epithelium is always resting on the basal lamina. So, but here, between epithelial tissue and underlying connective tissue, we can find basal lamina. Basal lamina, very important structure, and it's polarized cells. That's why such cell has different surface. Cells that face to basal membrane we name as basal, opposite apical, and to lateral. Such polarization of cell possible only in epithelial tissue. Nutrient blood vessels are located in sublying loose connective tissue. Here, this is structure, this is blood vessels. And epithelial cells themselves, or the layer of epithelium, possess the structural signs of polarity due to presence basement membrane. Now, this property is not referred to morphological features, to physiology. Yes, high regenerative capacity. When we consider cellular composition of population of epithelium that we refer to renewing population, there we can identify stem cells. Usually it's localized if its epithelium consists of several layers of the cell, what these stem cell cambial elements. After that, cell undergoes differentiation, all these, and specialized cell, for example, here, upper. If we can see simple layer of epithelium, this is villi of intestine, and villi of intestine and crypts. Stem cell or cambial elements will be at the bottom of crypts. And after that, cells became migrate to the top of the villi. On this way, they differentiate and specialized. And after that, they death and will be eliminated. Cell number in this population will be approximately constant. Now, some words about the cell surface specialization. Because basal membrane take part in polarity of the cell, and as I said, we identify basal, apical, and two lateral surfaces. We identify cell surface specialization. On apical surface, we can find cilia, in some cells, microvilli. Cilia take part in the movements. For example, in respiratory system, they move particles that we inspire out of our organism. Microvilli we can find in the cell of intestine. Main function of them is absorption. That's why it's necessary to increase cell surfaces, and that's why we can find microvilli. Lateral surfaces we can find intercellular junction that have different function. About them a bit later. And on the basal surface, we again can find junction that connect cells with basement membrane, and such invagination that we name basal invagination or basal enfoldings is synonyms. They also, as microvilli, take part in increasing cell surface for transportation substances. Так, сейчас, one moment. Сейчас. We continue with cell surface specialization, and in your working book, this class number 3. Apical surface, structure of cilia. Cilia we identify as projection of a cell, finger-like projection, and this part we name as axonema. And in the base of axonema we can find basal body with striated rootlets. Structure, basal body and axonema will be different. Look please, on longitudinal section, here we can see 3 lines, yes? On longitudinal section through the basal body, we can see only 2 lines. Why? If we cut transversely through axonema, here, we can see 9 duplets of microtubules plus 2 centrally situated microtubules. Oh, this diagram also 9 duplets and 2 centrally situated microtubules. If we cut and receive section through the basal body, we can see another structure, 9 triplets of microtubules without centrally situated microtubules. That's why centrally situated line absent here. Is it clear? Microvilli. Microvilli also projection, but they are smaller, and in the base of microvilli we can find actin filaments, microfilaments, that incorporate in terminal network under the cytoplasm of the cell. And these microfilaments, orientated vertically, they have additional proteins that joined and fixed these actin filaments between each other and with basement membrane, and after that they incorporate in terminal network. This is scanning electron micrographs of cilia and microvilli. Longitudinal sections through the cilia, microvilli, cilia, microvilli. You can identify microtubules here, so it can be 7 microtubules. So it's yes, cilia. If we can't see, we can see only gray color material. This is microvilli. On light, when we examine different types of epithelial with cilia, with microvilli, they look differently through the light microscope. For example, this respiratory tract, trachea, epithelium of trachea, we can see cilia very clear, yes? This is part of epithelium of intestine with microvilli on apical surface. It looks like as enlargement of apical membrane. we can't see separately microvilli, they less in the size. Again, trachea, this is cilia. This is epithelium of intestine. It's covered really of this epithelium. On the high magnification, we can see microvilli as enlargement of apical surface of the cell. Specialization of lateral surface. We can see different junction that join cells with each other. And cell junction have different function. We identify a group of occluding junction, example tight junction. Such junction not allowed to pass any molecules between cells. Mechanical attachments, no, this is only for Russian histologists, as junction for foreign histologists. To this group we refer adherent junction, spot or macule adherence, and zonal adherence. Spot dysmosome, bell dysmosome, and heavy dysmosome. And their main function joined with each other adjacent cells. Communicating junction, synapse, and gap junction. Synapse we can find in nervous tissue, that's why we consider structure of synapse a bit later. Gap junction look like the protein channels through which small molecules can pass from one cell to another, so they can communicate. Electron micrographs of this junction. This is apical surface, and what is it? What is it? This. What is the structure? We can see projection on apical surface. This projection, cilia or microvilli?
Microvilli.
Microvilli, you are right. Why? How you guess? Explain as a student.
Because it doesn't have 27
We can't see microtubules here. Yes? I remind you again. Look, please. If it's cilia, we can see microtubules here. When we cut it, what this one line, this one line, this one line. Yes, on longitudinal section. Microvilli, we can see only gray color material. That's why if we examine this, we can't see three lines. Yes, we can see gray color material. So this microvilli. And more close to the apical surface, we can see zonal occludence or tight junction. A bit later, we can see zonal adherence. This is another type of junction, mechanical junction, and macule adherence or dysmosome. On electron microscope, they look differently, but they have a general plan of structure the same. No, but such invagination of adjacent membrane of cell, this example of what lateral interdigitations. Gap junction I demonstrate it later. So, tight junction will be where two membrane of the cell joined very close to each other, and integral proteins anchor this, not anchor, fix this membrane. Let's look at here. This is diagram of tight junction. Tight junction, we can see transmembrane proteins that join with each other two membranes. That's why no any molecules can pass through between two cells. Spot dysmosome, mechanical junction. Two membrane After that, we can see attachment plaque, and internally two plaque intermediate filaments attached to this plaque. But opposite side of this plaque, we can see transmembrane proteins from both sides that anchor with each other. That's why we can see mechanical junction of adjacent cell. On electron micrographs, this mosome look like electron-dense material corresponds to this attachment layer. These lines correspond to intermediate filaments. And gray color material between two adjacent, these anchor proteins. Belt desmosome, ozonal adherens. It's situated as conjunction around all diametry. And it also consists of the attachment plaque, anchor proteins that anchor with each other from both sides of the cell, and to the plaque, not intermediate filaments, but microfilaments attach. Microfilaments. That's why, let's return to electron micrographs. This is electron-dense material correspond to attachment plaque. This gray color correspond to microfilaments because intermediate filament thicker in diameter. In case of the spot desmosome, we can see they more clear than in case of the zonal adherents. That's why zonal adherent, macro adherents more contrast than zonal adherents. Communicating junction, we can see channels that are formed by proteins. These proteins we name as connexins, and this channel we name as connexon. So, communicating junction or nexus consists of several connexons. Look like this. And if we use very high magnification of electron microscope, we can see the two membranes of adjacent cells situated very close to each other, as in case of tight junction. And we can see what these cross bridges correspond to these proteins. But sometimes on the low magnification, it looks like tight junction. That's why we can identify where is communicating junction, where is tight junction, only according to position. Let's look at this diagram. We can see cells that join with each other by a junction. More close to the apical, we can see apical surface. We can see tight junction all around the cell. Beneath it will be belt desmosome ozonal adherents, also around. Spot desmosome that joined with each other by intermediate filaments. And this below it, we can see communicating junction. Well, this is system of the junction in the cells. Basal surface visualization. We can see two basal enfoldings. It's necessary to increase cell surface for transportation, and also desmosome junction, hemidesmosome, that joined cell to basement membrane. For example, this cell membrane, this gray color, dark line, basement membrane, and cell anchor to the basement membrane using one half of desmosome. So we can see electron-dense material correspond to a plaque, intermediate filaments, and to this will be anchor proteins. Вот this diagram of hemidesmosome. Yellow color basement membrane, cell membrane, this flag, intermediate filaments, anchor protein. Very important structure, basement membrane, and on electron micrographs we can see very clear lamina densa with this. But actually, it consists of lamina lucidum and lamina densa and reticular lamina. So, cell joined with lamina densa using junction hemidesmosome, underlying connective tissue joined to lamina densa using collagen fibers that pass through anchoring fibrils. That's why epithelium and underlying connective tissue situated closely to each other. One more junction can appear in case of the other cells, not epithelium. Next, our tissue that we should study is connective tissue. Cells of connective tissue can move along matrix. For that, they produce such lamellopodia, and lamellopodia form temporary junction with substrate. They again, after that, form lamellopodia, form again junction, so cell can move. Such low focal adhesion, what here, microfilaments take part, and look please, red color, for example here, actin microfilament, small arrow sites of focal adhesion. This is, you can see, lamellopodia. This one more, fluorescent, immunofluorescent microscopy, actin filaments green color, vinculin of focal contact red color, again actin red, integrins of focal junction green color. And basal enfoldings, what this invagination of basal surface membrane, as I said, it's necessary for transportation. And tell me please, number 3, what is the organelle here?
Mitochondria.
Mitochondria, you're right. Why?
Because it has matrix and
double membrane and crystal. Yes, internal membrane form crystal. So if we can see a lot of mitochondria between invagination, what we can say about transportation? Is passive or active? Active. Yes. Now look please at this electron micrograph attentively. Can you say how many cells we can see here? One, more than one? And how you guess?
Can you ask that question again?
Can you tell us
How many cells here? Is it here information that allow to tell us how many cells or no?
No, there's not.
No.
yes. How many cells?
Cells, yes. How many cells we can see here? This is invagination of membrane, yes? Can we identify how many cells here?
Wallah, a lot of cells. A lot of cells.
How many cells?
How I can count?
One, more than one. Your ideas about this?
I'm thinking 2.
2. Why?
Because there's information on the outside.
No, we don't know. They got this invagination, and this may be also invagination.
So I think it depends on the tissue because for some cells
No, we discuss only this picture. That's all. This epithelial tissue. Who attended? Who attended?
هي واحدة one cell.
Tell me please, what is it? What is it here?
خايف أقول عربي صح.
What is it? Look like what? This and this. What this is two line. Yes, this may be invagination, maybe cell membrane. We don't know, but we can see what this electron dense and this electron dense. What is it? After studying cytology, after today's my explanation, this is junction between adjacent cell. What this, when two membrane very close to each other, tight junction, this is desmosome, zonal appearance. So if we can see junction possible only between cells. So let's count. This is one cell. This is one more cell, this next cell. At least 3 cells we can see on these electron micrograms. Now let's continue with epithelium. And all epithelium. Let's I explain. Oh, sorry. So, class number 3 devoted to cell surface specialization. So, task 14, structure of cilia. You should identify elements of cilia. Name according to errors, yes? Task 15, structure of microvilli. The same, whereas you can see errors, you should name this structure. Task 16, you can see diagrams of different junctions. So you should name this junction and not only name, function of this junction in the cell. Next, this table devoted to name of proteins that take part in junction. You can miss it. But without this table, only name structures of this name junction and name their function. Task 17, structure of basement membrane. Using presentation, for example, you can name elements of basement membrane. Task 18, you can see kidney tubula, which consists of a lot of cells with basal invagination. This is light microscopical level. Your task to draw one such cell, of this cell, using electron microscopy. So you should draw, because we can see with this basal striation that correspond to basal enfoldings. So this cell should be basal enfoldings. Nuclear, maybe some organelles, mitochondria you can add. And task number 19. This is task for you. And what you should draw cells here by what's describe function of this cell. For example, you should draw electron microscopical viewing of cell of epithelium, and you know that this cell lay on the basement membrane. Next, it absorbs substances and take part in synthesis and releasing some enzymes. if you know your function, this function of this cell, you should draw electron microscopical viewing of this cell. Watch organelles, take part in the synthesis of enzymes, for example. So, is it clear?
Yes.
Thank you. Let's continue with task class number 5.
Fine.
5, yes.
Okay. Actually, let's go.
But not задание 5. No задание. Занять 5. Should I занять 5? 5 or this? 5. This. I explain you this.
For next session, we should
And to the next class, you should prepare number 3 and number 5.